Okay, so this problem says a disc between vertebrae in the spine is subject to a shearing force of 600 newtons. Find its shear deformation using the shear modulus of 1 times 10 to the 9 Newton per meter square. The disc is equivalent to a solid cylinder, 0.7 centimeters high and 4 centimeters in diameter. Okay, so here's the disc, 0.7 centimeters high and a diameter of 4 centimeters. By the way, so it's a circular cross section. Here's a top view. Okay. And a shearing force is a force like that. So what happens is when you bend over or something like that, you apply a shearing force on your disc, and your disc is deforming. Okay. And I guess it exerts a pressure on your spine or whatever. All right, so what we're going to calculate is, of course, this is going to deform, and this is a highly exaggerated diagram. And this is called delta x. Okay, that is the shear deformation. Okay, by applying that force. And you guys understand this greater F is, greater this deformation is. Okay, and greater the deformation, greater the discomfort or whatever that you'll feel. Okay, so shear modulus is F over area, the stress. So it's this force divided by the area of this face divided by shear strain, and this is how shear strain is defined. H is the height or thickness of this thing. Okay. And what they're asking you to find is find the shear deformation. They're asking you to find delta x. Okay. So delta x is F over A Alright, so let's go ahead and put these 600 newtons by, the radius is 2 centimeters, H is 0.7 centimeters, and shear modulus is 10 to the 9 Newton meter square. Okay, so this will work out in, this will all work out in, the meter square cancels with that, Newton cancels with that, and this will work out in meters. So let's take care of powers of 10. This is 10 minus 4. Well, one of the 10 minus 2 cancels that. 10 minus 2, that becomes 10 to the 7. 2 gets killed there. 10 to the 5, that comes to the top. So that's 6 into 0.7 divided by pi into 4 into 10 minus 5 meters. Okay, so that's what it works out to. I'm trying to think. This is a micrometer. The size of a cell is roughly a micrometer. So this is deforming 3 cell width. That's not much.
How much would it take to bend over doing that much damage like this?
I'm sorry?
Every time they bend over.
Well, so it's elastic behavior. So, I mean, you want to be able to, be able to do that over your lifetime millions of times. So, you're hoping every time the disk comes back to its original shape.
How much deformation would it take to really do some damage?
So, well, this is when the damage happens. The damage happens when maybe the disk loses its elasticity. Yeah. When this number becomes small, that becomes large. So, I mean, nature has built us to be sturdy.
Yes.
It's when things get compromised, that's when damage happens. All right. Any other questions before we